Looking now at the difference between two-sided tests and one-sided test, specific to the t-test or group means comparisons. These are the objectives for Module 10, and we can now just simply look at them and say apply them to a one-sided comparison. So what do we mean when we say one-sided comparison? Well, the standard or default comparison that we've been looking at has a null hypothesis of mean A equal to mean B, with an alternative of mean A not equal to mean B. And this is what's called a two-sided test. Under the alternative hypothesis, you're looking for either A to be less than B or A to be greater than B. You're looking in either direction, so two directions or two-sided tests. But what if you only care about one direction? So let's look at the question this way. We can amend the research question to, is the mean of A greater than the mean of B, or is the mean of A less than the mean of B? So it's one of those. In a standard two-sided test, remember we were looking in either direction, less than or greater than. In a one-sided test, we're simply looking at one of those questions, and this really does matter. We are looking for A to be better than or worse than B, just one of those, not both. And you have an idea of the direction. If you don't have an idea of the direction, then use the two-sided test. A good example here is that this is frequently applied in clinical trials, where we're only concerned if the new drug A shows more improvement than the standard drug B. And in that case, we only look at the mean of A being bigger or greater than the mean of B. We do not use a two-sided test because we don't care if it's the same as or worse than B. We're only looking to see if it's better than. So we set up a new set of hypotheses, in this case, the null hypothesis of the mean of A being greater than or equal to B versus the alternative of the mean of A being less than B. You can see that these two hypotheses are still mutually exclusive, and you can also see that the equal sign still appears in the null hypothesis. Our alternative has changed. We are only looking to one side of that equal sign. The other option, of course, is that the mean of A is less than or equal to B versus the alternative that the mean of A is greater than B. So again, only use a one-sided test if you have an idea or you're only specifically interested in showing A to be less than B or A to be greater than B. So how does the analysis work? Well, in JUMP, this is exactly the same. You're going to do a fit Y by X. Our group is predictor, and that's X, and our numeric outcome is Y, and press OK. And it turns out the JUMP output looks exactly the same. Again, very basic, what you get from the one-way analysis, and you need to use the red drop-down arrow. The next step, asking for the quantiles and means and standard deviations, also exactly the same. The third step of asking for the means ANOVA pooled T, also identical. But here's where things start to change. Remember, our null and alternative hypotheses have been amended to only have a one-sided test. In this case, we'll look at the mean age for males being greater than or equal to the mean age for females. And then our alternative is that the mean age for males is less than the mean age for females. Here you want to look at the probability less than T p-value. And in this case, that's the lowest one on the pooled T test. And our p-value is 0.0569. While this is smaller, it is still greater than alpha of 0.05, and we will still fail to reject the null hypothesis. We will conclude that the mean age of males is not lower than the mean age of females. This is a big change from how we stated it before, where we stated that there was no difference. Now we're stating that we've concluded that there is no evidence of male having lower age than females. And our summary will change slightly as well because we want to include our one-sided directionality in the summary. So it is hypothesized that the average age zip riders is lower for males compared to females. The mean age of males is not statistically significantly lower than females. And again, give the same information. So there are 3 sets of hypotheses that we've looked at. The top set, A equal to B, A not equal to B, that's the probability of the absolute T. That's what we saw before in our prior video, the probability of absolute T. Then we have 2 options for one-sided tests. We have A less than or equal to B versus A greater than B. And you want to look at prob greater than T. Or A greater than or equal to B versus A less than B. And in this case, you want to look at prob less than T. So you want to use the p-value that's associated with the alternative hypothesis direction. So you can see for the top set of hypotheses, not equal to, that's the absolute value of T. For the second or middle hypothesis, that is greater than, and that is the p-value that you use. And for the third set of hypotheses, that is less than, and that is the p-value that you want to use. So in summary, one-sided tests are used when you are only interested in a greater than or less than comparison. The equal sign still remains in the null hypothesis, and HA either becomes greater than or less than. Align the p-value and jump associated with the null and alternative hypotheses that are correct for you. Compare to the alpha for your decision. Alpha still remains at 0.05. And include your directionality of test in your summary. What you report remains the same in terms of means, standard deviations, N and p-value. You just need to use the corrected p-value for your one-sided test.